We're solving problem 16 to 17 from the 2019 F equals MA exam B. The following information applies to 16 and 17. A hoop of radius r is launched to the right at initial speed v0 at ground level. As it is launched, it is also spun counterclockwise at angular velocity 3v0 over r. The coefficient of kinetic friction between the ground and the hoop is mu of k. How long does it take the hoop to return to its starting position? From our Newton's laws, we know that F equals ma. It's literally in the title of the competition. And friction is equal to inertia times alpha. This can be manipulated into acceleration equals force over mass, or simply mu of g. This is mu of k, but we're just going to keep it mu because we're going to plug everything in the end. Now, similarly, alpha becomes friction over inertia, or mu of g over r. So then we have that, and so now we know that velocity of time is equal to r omega of time. So then we can start solving by plugging these such values in. We know that for the velocity, negative v0 plus at, and then this is r times w of t, which is this is going to be equal to omega 0 minus alpha times time. Now this goes out, and we know xa is going to be mu of g, so negative v0 plus mu gt is equal to r, and then w omega of 0 is, well, in the problem it literally says angular velocity 3v0 over r. Since w0 is angular velocity, this is going to be 3 v0 over r minus alpha t. Now these r's cancel with this one. This becomes negative v0 plus mu gt is 3vo, and then minus, well, we know that we know that alpha is mu of g over r. So these r's also cancel out, so this just becomes mu gt. We get that time is going to be equal to 2v0 over mu of g. Now, we also know that, well, for this problem, v of capital T, this is equal to, well, negative v0 plus xa times our time period, 2v0 for mu of g is equal to v0. So this shows that our time period is correct, and this is how long it takes for the hoop to return to the starting position.